Hey, ladies and gentlemen, let's talk about ions and oxidation numbers. First atom says to the other, I lost an electron. The other one says, are you positive? That is positively hilarious. All right, so let's talk about our first kind of ion. These are cations. They result when an atom loses valence electrons and becomes positively charged. Now, why so positive? Because kittens are cute, guys. Kittens are really, really cute. That's why I'm putting all these positive charges here. So losing valence electrons makes you positively charged because remember, electrons are negative. So what about the other kind of ions here? Well, we have anions. That's the opposite. That's when an atom gains valence electrons to become negatively charged. All right? And you got a little Walter White comic down there for those of you that are Breaking Bad fans. He said, I got this extra electron I didn't want. My friend said, don't be so negative. You are hilarious, Walter White. So gaining an electron makes you negative. Another way to remember this is An ion means a negative ion. An ion, a negative ion. All right, so hopefully that'll be one way that you guys can remember anions. All right, so talking about oxidation numbers, these are the charges that result from the loss or gain of valence electrons. So when you're looking at the s and p orbital families, that's 1a, 2a, and 3a through 8a, you have to ask yourself one question. Is it easier for the atom to lose the valence electrons it has or gain more to get a total of 8? Well, let's take a look here. Let's look at something like magnesium, for example. We know magnesium has 2 valence electrons, right? Is it going to be easier for magnesium to lose those 2 or gain 6 more to get a total of 8? Well, it's going to be easier for magnesium to lose those 2 valence electrons and therefore has a resulting charge of positive 2. So it lost 2 negatives and got to be positive 2 as a result. Let's look at another one. What about oxygen? Oxygen has 6 valence electrons, right? Is it easier for oxygen to lose those 6 or gain only 2? And if you said gain 2, that is absolutely correct. If it gains those 2 electrons, it gained 2 negatives and as a result has a charge or oxidation number of -2. All right? So I got a periodic table here for you guys to look at just to show you a couple little tricks. I want you to know this. Everything in this family right here has a +1 oxidation number. Everything here in family 2A has a +2 oxidation number. Everything here, +3. Of course, there are always exceptions to everything, but this is just a general rule of thumb. Here, where we have 4, well, it's going to be 4 plus or minus. Okay? And then we get into the negatives. Then we have here 3 negative. Here is 2 negative. And here is 1 negative, if I can fit them all in there. So, +1, +2, +3, plus or minus 4, and then -3, -2, and -1 as we move down. That's based on whether it's easier for them to gain or lose those valence electrons. And then, of course, we've got the noble gases, no oxidation number because they already have a full valence shell. Okay? Hope this helped you guys out. See you next time.